the course Multi-Core Computer Architecture. I appreciate all of you, those who are joined live, and some may be watching it live through the YouTube link that is already been shared to you. So once again, for all those who are taking this course seriously, I wish all the best. We have just completed 2 weeks of this course, and just like a quick briefing of certain common things that are there. So those who are already online, kindly submit if you have any queries on the forms that is already shared in the mail, so that I have an easy access to it. I will get back to your queries. You can also type it in the chat box, either in the Google Meet link either in the YouTube chat window or here in Teams, wherever you have joined. Our backend team would be able to coordinate that. That's regarding this. And the first thing that I wanted to mention is the course enrollment is already over. Now we have come to a stage wherein we are seriously taking this course. So there are two categories of participants that we typically get in an NPTEL course. Some are passive learners. They go through the videos. They may solve some of the assignments. And some are taking this course in order to credit this course, to take a certification, the NPTEL online certification. So for that, the examination is already scheduled on October 28th. That's a prefixed date that is there. You can already see that in the course webpage from NPTEL. In order to do the arrangement and logistics across the country in various districts, we need some time for arrangement. So August 14th is kept as the last date for enrollment for the exam. Once you come to know how many candidates are there, accordingly, they have to schedule the exam in various cities. So that is one important aspect of it. The next aspect is if by chance you are not able to do the exam registration by August 14th, then up to 18th you can do with a late registration fee. So 1,000 rupees is for registering for the exam, and up to August 18th you can do with a late registration. So thereafter, NPTEL may not be able to accommodate your request because it requires a lot of time to coordinate the effort. So that's with respect to that. And then while giving the exam registration, you can choose maximum 3 cities, and NPTEL try to see to that whether your preference 1 and preference 2 is being given. But in the worst case, when there are so many number of candidates, any mapping and scheduling issue, if it is there, sometimes it can go to city 3 also. So to avoid that, carefully choose your 3 cities of the order, such that on the exam day you need not travel much. But due to operational constraints, NPTEL always reserves the right to add a new city or to remove an existing one and allot a city that may not be there from the choice. It may happen, unlikely less than 1%. I just mentioned that also. So keep in mind, August 18th is the last day with fine if you wanted to enroll for the exam. Now, typically coming to these courses, we have close to over 6,000 students who have registered. So please try to understand every Friday, the new set of videos will go live. And then typically it contains some lecture sessions and some problem solving sessions, what we call it as tutorials. And we have the discussion forum also, wherein you are free enough to send your questions, and our team will get back to you regarding to address your queries, and typically give at least a day time, 24 hours time to get back to the queries, because our backend team and myself, we won't be looking at these queries for every hour. So we have typically fixed some certain number of hours every day. Let's say evening 4 o'clock. So you wait for minimum 24 hours in order to get the queries. And if the query requires more learning from my side and my team side, it can take sometimes 36 hours also. So even after 36 hours, if you are not getting the response back, kindly flag it. We will be able to take it up on an urgent basis. Normally, we will respond in time. Assignments are due on every Wednesday. So today being Tuesday, tomorrow is the last date for assignment 1 and assignment 2. Thereafter, every Wednesday, it is a due date for assignment 3, 4, like that. Every assignment, there are maximum up to 10 marks, and then few multiple choice questions and some numerical answer type questions are there. To score well in the assignments, those who are crediting this course, one simple thing is go through the videos that is being posted. So you roughly get close to 12 days for submitting the assignment. Go through the videos carefully. Every week, then we have scheduled in such a way that every week there is one tutorial video kind of thing, which is typically focusing on numerical problem solving as well as to design questions. So it would be good if you go through these tutorial videos or whatever we call the special focus videos to get a more clarity on it. And once the deadline for assignment is over, we will post the solutions with the detailed issue is there. That is also being posted. Then the next aspect is with respect to the preparation level that is being required. Assignment questions are simple and straightforward. So I request you to go through the lecture videos first and try to solve with the numerical problem video that is also being posted. And looking and referring into old NPTEL material of similar courses, advanced computer architecture and multi-core computer architecture also will help some of you. So don't wait for the last day. You can very well score. Since the assignments are due and it is part of the marking thing, I won't be taking up any questions pertaining to the assignment questions today. But if there are any questions outside the assignment that has been already posted, I would be taking it. It's because of it won't be fair because for students who are going to submit their assignment tomorrow. Okay. So we will be taking, you can put up your queries in the chat box as well as in the Google form that has been shared. So for the final exam, we get to close to 40 to 50% of questions are directly taken from the assignment. So the detailed solution of assignments also would be put in. And we are planning to have one live session every month. And if at all there is a need, we would be happy to take one more. So kindly be active in the discussion forum, and wherever there is a requirement, you can put up things. So we will float a form such that we will be directly getting your feedback. And things are very simple. It has been started from week 1, keeping in mind those who are not from computer architecture background also, they would be able to learn. We have started from the basics of program execution, the computer hardware, and then we learned about instruction encoding and the instruction pipeline. This many things are over. Week 3 and week 4 would be of slightly advanced one. And then we learn about a little bit more advanced features in the subsequent week. So my request is go through the videos. You always have the freedom to stop, rewind, and hear it again. 1 or 2 times if you hear, the concept should be very thorough. And in sync with that, try to learn the textbooks that are being mentioned as the references. This will give a complete good learning. Scoring 65 to 70% of this marks for this course is completely very easy if you stick on to the assignments on time. Even if the assignment is, let's say, 1 or 2 questions are tough, it is okay. You can get 8 out of 10 marks. One question may be slightly tricky. So, but if you start very late, it would be very difficult for you. Please understand, assignments you can discuss between your friends and then submit. Whereas you don't have that kind of the leverage or luxury when it comes to the final proctored exam. Okay, so with this background, let me go through some of the questions. We already got it. So let me take them one by one. So there are some generic questions. So one question, it is already posted by Tejas Vipin. Why do load word and store word instruction in MIPS architecture always use an offset from memory location stored in the source register? Why can't we just store the memory location after offset in the register? So this is a question where I have a store word instruction, the LW or SW, R1 with an offset followed by a base register. This is typically used such that I can keep on changing the scalar value of the content of the registers, let's say 8 of R1, and R1 content, if you keep on incrementing, it's always give you a displacement mode of an addressing. From a particular base location, I can advance to location. So by simply updating one of these registers. So in this way, while we are trying to access some continuous locations like arrays and structures, keeping the value constant, keeping the scalar value constant, I can get into new addresses by simply updation of this. And the second one is the width that is available inside the instruction register that may not be supportive enough if you wanted to have 2 registers that is being put up. So that is the answer to Tejas Vipin's question. And then we have second question pertaining to this. Is this course computer architecture used in AI or ML? So kindly explain. That's a question from Jeet Bharati. So Jeet, the answer is artificial intelligence and machine learning. These are some of the sophisticated algorithms that is being used for solving certain class of computer science problems. And generally, any kind of computer science problem is typically solved with the help of a computing machine. The machine can be something of the level of a cell phone, handheld devices, laptops, or it can go to personal computers, supercomputers, workstations, servers, and all. So any kind of problems, be it AI or ML or robotics, whatever kind of applications that you see, ultimately it has to be done on a computing machine, which consists of a processor, its associated memory hierarchy, and a communication mechanism for the rest of the world. There are general purpose processors wherein at the time of fabrication, we don't know what are the applications that is been running. The second category is there are application specific processors where at the time of the design itself, the architect know what category of application that are going to run. So accordingly, I can customize the hardware. So if I am knowing that this application that is going to run is an AI ML related application or application that make use of AI ML principles, then accordingly, certain specialized hardware components can be added, something like accelerators. So knowing a basic computer system and then using that computer system for your application is one way. Second one, you tell your application is this, so I want certain features, certain enhanced features in this hardware. In both these cases, we want to know about basic computer architecture, how instruction execution happens, what are the basic fundamental hardware concepts that you need to understand. Next question is, why am I studying computer organization and architecture? I am reading these questions from the forms that has been already been shared, Google Docs forms. Computer organization and architecture is a fundamental course that every computer engineer or an electronics engineer learns because this is the course that will give an understanding about how basically things work at the hardware level. Right from a storage, from a memory, from an instruction standpoint, what is a fundamental way in which an instruction execution takes place? What are the basic operational concepts? How various units inside a computer or a processor are being interacting, and what are the kind of signals that are being exchanged? So only if you know the fundamental, the base level, the hardware is thorough, then only when it comes to an operating system level, your confidence would be good. And then on top of that, we have the networks and then the application that is being built. So fundamentals of computers consist of basic processor, its peripheral, its memory that connect. Understanding it's really required if you wanted to do some task on top of it, and you can execute a task in the most efficient way. What is the importance of this course in computer science? Another question by Alok. So in computer science, generally we can look at two things. First one, you make use of computer to do certain tasks. Second one, you come up with better computers so that others can do tasks more easily. Computer scientists, computer architects basically belong to the second type where we come up with architectures with modifications that can help in coming up with better hardware, better architectures such that latest state-of-the-art applications can run it. So to summarize, two-way, people who use computers just for the sake of using it, you have a defined hardware, you have an existing hardware. On top of that, we use the hardware in order to get our task done. So we don't really care about whether the hardware is good or bad. Whatever is given to you, that's considered as a black box. You write program and get it. Second one is called computer architects. They try to understand the diverse set of users that are going to work with computers. And according to their need, we come up with architectures that are most suited for running these applications. So if you belong to the second category, then basically working with computers knowledge is being required. There are some similar course kind of queries like what are the benefits of this course? Why should I study this? So the all answer is understanding how a basic computer work from the standpoint of an instruction running is what is being covered in this. Describe COA in real life in simple sentence or a word. That's a question from Sobit. So if you look at the COA from simple terms, there are two ways in which if I look at, let's say you have a car. You are a driver. Think of the case, then you know the basic driving rules, principles, you can drive the car. That's called a driver driving a car. If you are a computer architect, then also you can drive. Then it's something like a mechanic driving a car. You also know the basic driving principles, but regarding fuel efficiency, regarding how engine works, how gearbox works, how are the ways in which you interact. If something is not working, or if you are facing that, if you give acceleration, car is not going with the same throttle that is being expected. If you are a mechanic, then you will come to know either there is some problem in the fuel chamber or in the engine hose or in the spark plug. So it's always a difference between a driver driving a car and a mechanic driving a car. So that's a real life example. So someone has asked, Ananya has asked about, I need a better awareness about the course in a detailed manner. So I request Ananya to go through the introductory video of this course, which will cover up various aspects that is being touched. And so in that way, and then a detailed description of the week-wise split up is also given, what is being that is being covered. So over the weeks and then the introductory session of each of the lecture video also we are giving what is being covered. And there is a summary that is being given at the end of the lecture. What is that we just learned in that particular week. And then the connectivity between the lectures are also being given. So there are a lot many questions regarding scope of this course. All this been referred. Now coming to the scope, we have to understand any job that is there in the computer science related domain. One is called a software engineering profession, where you make use of computers, you write applications on top of it, and these applications are making human life easy. For example, a retail application that you write, then a program, a software that run in a supermarket, in a retail shop, okay, or in a textile shop, wherever it is. The second kind is it can be application related to banking, application related to ticket booking, application related to crowd management, your payment windows. Let's say you make some payment in government portals, tax filing. So these are all applications, software applications that are being developed, and majority of the jobs in the country comes with this information technology related jobs, IT related jobs, where you are into developing software that is going to help humans' life easy. The second category, which is of slightly higher level of computer science job profile, is about systems building. We require, so the kind of laptops or cell phones that you have 3 or 4 years before is not there today. Today we have more advanced versions of laptops, advanced version of handheld devices. Have you ever thought of who makes this? It's also people in electronics and computer science domain are also working behind that. Their job is to create systems. So people sometimes are thinking about computer science engineering is all about how to write good programs, learn 2, 3 programming languages, and then you do. That's one kind of a job. I will tell that it's a little low-hanging job. Whereas the other one is about building powerful systems. You are part of new processors that has been being manufactured, being developed. You are into R&D. How can you improve performance of communication? How can you improve performance of downloading something from internet? How can you watch streaming more better? So there are system builders, there are application builders. So the scope of computer architecture course is you can focus your job more into system building. And typical companies wherein people with a computer organization and architecture background are being hired are one is in Intel, then in AMD, then in Qualcomm, then we have HP, we have IBM, and you name there are a lot of companies which work in this domain where systems are being built. Samsung, Nokia, to name a few. So one of the other question is how describe the future scope of computer architecture. If you look at this course, over the years, we are seeing that more powerful computers are been coming. Something 10 years before we could never think of. We can have a video streaming that is possible in a cell phone. Nowadays, we are watching videos in cell phone, movies in cell phone. So the computing capability, the processing capability, the capability of connecting to Wi-Fi, connecting to data, connecting to 5G or whatever it is, they have drastically improved over the years. So in future also, we will get more computing power, more computing capabilities to our handheld devices. So the future of multi-core computer architecture is about people who know the underlying infrastructure, the underlying architectural level description of these machines. And of course, since always the future is going to be highly computer-centric, highly connected to devices, working devices, sensors, then there is a lot of scope for this course. Next question is how can we come up with a new architecture that is more efficient and powerful, and how can we code this in Verilog HCL? So this is a question from Keshav Joshi. Good question. So with this course, what we do is we give you the basic concepts about basic computer architecture, and then we will introduce you some advanced computer architecture. We'll take up some case studies. We'll solve many questions. So at the end of this course, you are in a position to learn state-of-the-art research material that has been published from the industry houses. So many of the terminologies are already been familiar to you, which was not familiar at the beginning of this course. So over the years, you will get more comfort when it comes to the understanding about the state of the art. Once you know this, then any kind of advanced research paper you will be able to read and understand. And sometimes if you have some grip on simulators, grip on hardware description language like Verilog, BlueSpec and all, you can write your own smaller modules and then check. So people who are interested in this higher level of learning, obviously we can have one-to-one interaction once the halfway of the course is been done, and we'll be very happy to help such kind of enthusiastic crowd. So there is a question about, we wanted to ask about storage and interconnects, where it is used and all. So this course is multi-core computer architecture. It is not related to storage and interconnects. There was a previous course from me with this special focus given to cache memory and on-chip interconnects. Now this course, multi-core computer architecture, will deal exclusively with the processors, with the memory, and then the interconnects. So the focus will be more, if it is storage and interconnects, focus was more on cache memories and network on chips. So the final exam, it is going to be held on 28th of October, and the questions should be from your YouTube lectures or from LMS, which I get in the college. So see, those students who have enrolled in this course, you have the learning management system where the assignments are being putting, the slides are put. So the YouTube videos that have been shared in the LMS one, that is what is we follow. So go through the assignments, what has been there. The detailed solution of the assignments also would be ported in the portal of this course. And the videos are same. So don't get confused with my old course, multi-core computer architecture, storage and interconnects. Go through the videos that are coming through the portal, the NPTEL online portal, through which you have done the course registration, through which you are submitting the assignments. So there are plenty of questions from any side regarding what is the scope of the course, what are that we are going to learn, what are the applications. I have covered almost all of them. And now let me go through some of the questions that are come here in the NPTEL chat. So somebody is facing issues in enrollment of the course. There can be an extension of the last date of assignment submission so that I can solve these issues. So I won't be in a position to answer to that. I request you to write to NPTEL team. I don't know whether an extension would be allowed. Already it has been assigned an extension. So what is the problem that you faced? Then you please try to write to them. They will be able to do, since it is a technical issue. And the next question from John Fernandez from Qualcomm is, what is the best way to achieve high performance and low energy consumption simultaneously in a processor? So this is very early to tell at this point because we have just started this course, John. Please understand, over the rollout of this course, we will learn about many optimizations that we have, wherein we will be focusing on performance. Certain optimizations are on performance, certain optimizations are on energy consumption. So we will come up with various techniques over towards the end of this course, where we try to understand the behavior of the programs and to see what hardware feature is really required. So energy consumption can be achieved if you complete a task early, or you can turn off some of these units, something like power gating that you use. So energy can be saved. At the same time, you can achieve performance by optimization. So once we talk about architectural optimizations in processors, as well as cache memory optimizations, we will be in a position to take this up more. So since we have just started, some of the terminologies that I used to describe about energy consumption and performance may not be familiar to the rest of the audience. But I'm sure I will take up these questions as this course progresses with specific examples that is being quoted. And similarly, there is another question, which is better pattern for multi-core architecture, recursive threads or map-reduced threads. Is there any quantitative measurement that you do? So in multi-core architecture, since this is also now a question that you will be typically encountering towards the end of this course once a multi-core architecture has been introduced. But just to give a quick answer to it, generally we have to see when you run with the kind of multi-core setup, we are always looking at weighted speed up. It's not only about one core that has been running fast. You need to have programs across multiple threads, and these multiple threads are going to give you performance. But sometimes you work in a multi-programmed environment where you have multiple programs running, one in core 1, other one in core 2, like that. So in that case, a weighted speed up and an overall system throughput, these are some of these quantitative measurements that we use. Now, so if there are any queries in the YouTube streaming also, kindly post it there. I couldn't see anything there as of now. Okay, so there is a question from Kalyani Devi. Can we use multi-core architectures in low-power VLSI to modify circuit for projects? So multi-core architecture, now if it is for a simple project, a standalone project with a small processing capability that you use, then multi-core architecture may not be helpful. But if you look at any kind of a processor-based system that you have, it will be having a small processor plus some memory plus some interconnect. So the concept of cache memory that you will learn in this course, the concept of scheduling, the concept of out-of-order superscalar processing, the concept of program instruction rearrangement for reducing the stalls, the interconnect mechanism that we learn, many concepts, fundamental concepts that we learn may be helpful for you in this project. But your project may not be using a multi-core architecture sometimes. Project may be using a simple single core processor and all. So there are various concepts assigned to processing side, memory side, and communication side, which will surely help it. So there's a question from Shobit, are we going to learn Jump 5 in this year? So in previous courses, it was there. This time from the course, the Jump 5 has been removed as the mandatory clause. But if someone is interested in learning Jump 5, you can always contact, and then we are planning to have a separate session for those who wanted to learn about the Jump 5 simulator. But this year in this course, we are not going to have Jump 5 as a component. So another question is, what is the difference between multi-pipeline and multi-threading? See, multi-pipeline means you have various units, like you fetch an instruction, and then depending on what is the instruction, either you go to the integer pipeline, then it's a floating point pipeline. That is called multiple paths, single entry, multiple paths and exit. That is called a multi-pipeline. We also use the term multi-pipeline whenever you have parallel instruction pipelines. When you wanted to fetch two instructions, decode two instructions. So that is called this parallel pipeline that you use. Multi-threading has no connection with respect to this. Multi-threading means you have multiple smaller processing units. One instruction is there, one task is there. I subdivide the task into multiple smaller execution units, which are known as threads. So let's say I wanted to add A plus B as a huge matrix. I can divide the matrix into four smaller submatrices, and I can divide it into four different smaller processors. They will be doing that each one individually, but at the end I can. So it's a scatter the data, process it parallelly, and gather it back. This can be something related to multi-threading. So that's all the question that I see in the YouTube as of now. Let me see if there anything else that has been coming. So in the meantime, if at all any questions are coming, I just wanted to tell the learners one point. As we go to subsequent weeks, you may find that certain topics are slightly difficult and advanced. Please do understand, go through the videos one or two times, make use of the discussion forums to understand your concepts well. And still, if it is not clear, post your queries. Whenever we have the live sessions, we will be happy to take care of them. So if there are more number of queries, we can have one more live session in the month of August itself, depending on the requirements. That won't be a problem to start a new live session from our end. But please make sure you learn early, sufficiently early, and submit the assignments on time. And for those people who are not looking for crediting this course or taking the certification, you look only for the learning purpose. I also request you to try to solve the assignment so that you can check it out, what kind of learning that you had. And from the feedback that we have from the previous courses that I offered, surely students are able to grasp a lot many concepts. I have made the lectures in such a way that a lot many real life examples are being mixed into it so that the concepts are being learned in the very simplest possible way. But at the same time, you need to have a grip on the underlying working, and which sometimes these numerical problems, what we call it as tutorials, that is also being kept in every week for your understanding. So unless you spend 3 to 4 hours in a week, maximum 5 hours in a week is sufficient enough to clearly understand. Every Friday, the videos would be up, and thereafter another 12 days by next Wednesday. Then, so suppose if the video is up by Friday, the Wednesday after that, no, leaving one more week. So close to 12 days that you get in solving these assignments, and then you do. There is a question from John once again. Thank you, John. John Fernandez. How are programs parallelized with the dual core processors? So program parallelization happens with a parallelization. There is a role that has been played by operating system also, where a single sequential program has to be done in parallel. But when it comes to dual core processors, it is the operating system that schedules which instruction has to go there. So if you see two independent instructions are not dependent on each other, two instructions, then I can schedule one in one core and the other one can be placed in other core. But if every line is dependent on each other, such a kind of scheduling may not be possible. So dual core programs basically work when the operating system clearly distinguishes task 1 and task 2. One is you can run two independent tasks in two processors. Second one, you can have a single task with multiple threads, and the OS scheduling is going to do the mapping. So we will learn about this mapping in the last week of this course. It is known as thread scheduling, a concept that is more closely aligned to operating systems. So one more question from Kalyani, good to see. Is there any difference between parallel computing and parallelism? So parallel computing is possible. That means to do computing parallelly is possible only if the task has an inherent parallelism within it. So if there is a task called A equal to B plus C, then you are telling D equal to A plus something. So if every line is dependent on the previous line, I cannot do any parallel computing there. So when a set of instructions exhibits parallelism, that we call it as instruction level parallelism, if it is there, only then we can do a parallel computing. What we learn in this course is infrastructure that will facilitate parallel computing. Parallel computing is a programming paradigm. And parallel computing can be done on a machine which has facility to run parallel tasks. So when you have multiple processors, when you have multiple storage devices, when you have facilities wherein I can parallelly communicate between A and B and C and D. So the infrastructure required at the hardware level, that is then one that is going to help your parallel computing. Mohammad Adnan Khan's question, do we learn anything specific processor like M4? No, we are not going to learn anything about special processors like M4. We will be giving you pointers, but I'm sure that with the background that we have in this course, any research material, any sophisticated specification of any of the latest processors, you will be in a position to understand. Because the terminologies, the basic terminologies are being covered. Lot many feedbacks that you are enjoying this course. It's good to hear that our effort has been very fruitful. People do enjoy the course, so please continue learning. There are some topics which may be slightly difficult, but don't lose interest in that as well. So there are questions which talk about there are 4 instruction set architecture. Currently, which architecture is used in latest processors? Latest processors are generally memory, the register memory architecture or known as CISC architecture, and some of the processors used in handheld devices, cell phones are all RISC architecture generally. But nowadays, with a lot of optimizations, we are able to improve performance of RISC to CISC level and CISC back to RISC level. So it's a combination of register memory architecture and load store architecture that have been used in latest processors. And Satyagam Tyagi, you have to understand the question that when you talk about latest processors, there are many latest processors. Some of them are customized to handheld segments like your laptops, your cell phones, and some has been used for servers to workstations. Both are latest. So the term latest is a very generic term. But if you are being very specific, let's say handheld devices wherein power is a constraint versus workstation where the throughput is what is the important parameter, then the kind of architecture used is going to be different there. So if there are no questions, I think we have to wind up. But if you have any queries, either post in YouTube video or you can post in Teams, depending upon where you have joined. We'll also put this live session also into there in the course management system in the portal. So those who missed the live session can also learn it. Okay, so we have something from Pravesh Srivastava, data science professional. So he's more interested in a job which has domain both in hardware and software. I want to switch to that career. What are the follow-up courses should I take after this? So it's a very good question. Thanks for the interest, Pravesh, shown in taking this course. So you are working on data scientist. So what you have seen is previously your data has been considered as a separate entity on top of a hardware. You were never bothered about what is that is in hardware. You have a computer. On that, you need to do some data processing. You need to handle huge data, and then you write applications or programs which can manipulate and handle this data. But over a period of time, people realized for applications like huge data handling, big data handling, conventional general purpose microprocessor based computers may not be sufficient. You want specialized application specific servers, application specific workstations, which may have maybe a processor with these features are really good, or a processor or a memory in these features are typically very good. So if you know, that's the same thing what I told. If you know the systems domain very well, and then if you want that looking for follow-up courses, a course that you do in operating system, advanced operating systems and cloud computing or networking on top of the multi-core computer architecture, that will give you a very strong base on systems. So even if application changes, there is always a high demand for people who are strong in systems domain. Because many a time hardware related courses or architecture related courses are not given big emphasis. So people always try to feel that computer science is all about writing programs, but anybody can write a program, but only from an engineering mindset you can learn an architecture course. So kindly continue your passion in data science. At the same time, you make sure that you learn the hardware platform, you learn so what I typically tell: computer architecture, operating systems, and networks. These three, if you are very strong, that means you are a good person as far as computer systems knowledge is concerned. And then if you learn good algorithms and programming language, that's a perfect recipe for a good computer engineer. I hope I answered Pravesh query. So are there any resources you would recommend for continuing with the subject after this course? So with this course, I have prescribed certain textbooks. Going through textbook, and sometimes if you wanted to learn solving some numerical questions given at the end of the textbook chapters, that also would be helpful. That's what I feel. So apart from that, attending the lecture, solving the assignments, and solving the solutions given in the textbook, that is good enough. So we have question like how hypervisor support dynamic increase of resources like CPU and RAM. So I think considering the heterogeneous audience, the hypervisor concept is coming in operating system. On top of a hardware, you provide a virtual platform so that it acts as OS, and then that increase resources like CPU and RAM. One application can steal cycles for the other application. So one hardware, you get a multiple operating system feeling. That is what is called the hypervisor does. So it abstract out and it provides internal communication at the kernel level such that unused resources for one application can be shared to the other resource. In that way, hypervisor helps. But that's much outside the scope of this course. But it's good to see that people are asking curious questions from that. So Satyakam Tyagi, one more question. What's the name of programming which instructs the processor such as program counter add 4 bytes? Name of the program. See, this program counter adding 4 bytes, it is not relevant to any programming language. It is the underlying computer hardware architecture which facilitate program counter is equal to program counter plus 4, because when you operate upon hardware where instruction size is 4 bytes. So you have a separate adder. That adder is being continuously updated based upon the instruction that you fetch. So as long as the instruction is 4 byte long instruction, The special adder, which is connected to the program counter, which is integrated part of the instruction fetch unit, will facilitate this. It's not related to any programming language. Okay, so then there is a question. Let me see. Okay, probably I could not see all this. Somebody was asking about Keller. Yes. So somebody was asking basically about Jim B. Keller. As you know, Jim B. Keller is an American microprocessor engineer who is best known for his works at the AMD and then Apple. He was one of the lead architects of AMD K8 microarchitecture, and he was involved in many of the crucial design in Apple for A5 and A5 processors. So it's good to know that people are reading about people wanted to become like Jim Keller. So all what you need to know if you are looking for targeting for someone big as Jim Keller, the fundamental knowledge in computer science is important. It's not about programming language. Fundamental knowledge is based on how computer works, its hardware, its interaction with various components, microarchitecture level understanding that will give you a good grip. And then learn how the interface of processor and the operating system is, how the interface of operating system with respect to application is. So once you do hardcore understanding about architecture, operating system, then writing beautiful programs on that is easy. So it's a fundamental subject clarity that matters if you wanted to become somebody really great in this field. So if you are going to make your own processors, how do you give instructions? So when you are going to make your own processors, you have to design what is going to be the instruction set architecture. What are the set of instructions that are being supported? So the instruction set architecture is the heart of it, and accordingly you have a control store. Once I fetch an instruction, depending upon once I decode, then you will be able to understand what instruction it is. And then your control store contains a set of control signals to be generated upon understanding each of these instructions. So the instruction set, the control unit together will act as the brain. So we have one more question from John Fernandez. Which accelerators do you think are going to be used in future architectures? What decides which accelerator to deploy in an on-chip setup? It's a very, very generic question. Accelerators are something that speeds up. So what do you mean by future architectures? There can be many things. What you consider as future may be different from what I consider as future. So future can be more in security domain. Future can be more in video processing related domain. Future can be more in connecting to more sensors. So depending upon what is the domain that you are talking, the accelerators are different. Sometimes I need to process multiple sensors together. So accelerators that have highest throughput is important. Sometimes if I am going to work with the complex math circuits about high-end quantum computing, security may be one of the future architecture. Then a good number crunching machine is what you require. So accelerators that can speed up high precision mathematical numbers, that may be a requirement. Sometimes you require accelerators that process vector data. Sometimes you require accelerators that process image data faster. Sometimes you require more number of multiplier, adder, and accumulator unit. MAC units are being required. Okay, and then sometimes you require accelerators that can quickly process GPS coordinates when it comes to a quickly fast-moving equipment that is moving across the space or something moving from one continent to another. So real-time data crunching is what is that is being required, and depending upon what is the application, the accelerators also will vary. It's good to see a lot of the interesting questions. So Mohammad Adnan Khan, there is a question. Can you explain how GPU architecture is different from processor architecture? Wait for week number 5, where I will talk about the difference between CPUs and GPUs. So GPUs are specially meant for handling only certain category of instruction, very small subset of instructions, where a CPU can handle a wide range of instruction. So it's a we can tell basically GPU is going to be a specialized processor, specialized in processing a category of instructions. And towards the end of this course, we are having a special case study on Vega processor. Vega is one of the indigenous microprocessor that is developed under microprocessor development program of Ministry of Electronics and IT. So Vega is developed by Center for CDAC Trivandrum. So they have come up with this Vega processor, and we are having separate case studies towards the end of it. So whatever concept that you learned towards the end, you will get a feeling of how these concepts, the pipelining, the cache memory, everything that is being there in one of the state-of-the-art indigenous processor developed in India. So Vega processor is a case study at the end. I think John Fernandez, some of your questions requires answer only if the fundamental concepts are being covered, or else whatever I tell regarding acceleration, synchronization of future multi-cores, everything can be done only if the multi-core is introduced. At this point, I surely take up this question. There is no problem in answering. But considering the audience, since they are only up to the very first 2 weeks of this course, we'll take up questions that requires more understanding about the course a little later. So any other questions pertaining to the first 2 weeks of this course? And tomorrow is the deadline for the assignments. So if you are serious about crediting this course, I request you to go through the assignments carefully and then please do submit. Okay, so since there are no more other questions, I enjoyed these questions. Keep on asking questions. Let's meet in the subsequent weeks. And wish you all the best. Kindly do take the course seriously. I promise from my side that you will enjoy this course. So with this, we are winding up this session. It was a close to 1 hour session. We look forward for a wonderful learning together with you. Wish you good luck. Thank you. We'll see you after a couple of weeks. Enjoy multi-core computer architecture. With this, me and my team from IIT Guwahati signing off. Thank you very much.